All right, folks, good morning. This is Mr. Walker coming at you with our notes for today. We are dealing with transformations, people. So we got a couple definitions and a few practice problems on the bottom that you have to go through and tell me which transformation is which. So let's talk about what transformations are. So starting out at the top, a transformation is a function that maps a figure onto a new figure. Now, below we have several transformations that we deal with. We got a translation, a reflection, a rotation, and a dilation. Let's talk about what each of these do. So, first one that we got on deck is a translation. So, a translation is a transformation that moves every point on a shape in the same direction and with the same distance. So here's our chess piece here. We got a knight. This knight is going to be sliding essentially. Now, no matter where we go through and move with our shape, you're going to notice that these are going to maintain whatever direction that they currently were facing, and they will also stay the same size. The size does not change. The direction that it was facing does not change. So remember that. All right, next one we got here is a reflection. A reflection is a flip. So this maps every point across a line of reflection. So it makes a mirror image. Now, if it's a mirror image, that means it's going to be the same shape, but our new version of it is going to be facing in a different direction. That direction it's facing is whatever line that we are reflecting over. So whatever we see over here, it is now flip-flopped over on the other side of the line. Things to remember, these are going to maintain the same distance from this line here in the middle. This isn't going to get further away than this is. It's just like a regular mirror in a house. Okay? Next one we got here is a rotation. A rotation is a transformation that turns every point around a fixed point, and that is called the center of rotation. So right here, this dot, that's our center of rotation. Let's take our piece. Let's see what changes up. So here's where it's at originally. Here's where it's at after. Things to recall, this and this, they're both facing this point here, our center of rotation. And things to recall, since this is turning things around, this will not be in the same orientation as it originally was. It's not like how it is with this or this, where they're both generally, right side up. This one right here, depending on how far you're turning it, may go either upside down, laying on its side facing up, or laying on its side facing down. Depends on how much you are rotating it. So we'll get into that once we get to there. Now, last one is a dilation. We've actually been dealing a lot with dilations with similar figures. Essentially, a dilation transforms a shape and it either reduces it or enlarges the figure. So, here's our original shape. Let's look at it being dilated. Now, this dilation here, it went from being a large one to a small one. Now, this is the only one of these four transformations that changes the size of it. All the rest of these, if you notice, are around the same size as the original one. So keep that in mind. This can either go from being big to small or small to big. Depends on what we're looking at, okay? All right, let's get some more definitions, folks. We're going underneath the four boxes on your paper to the rigid motion definition. So, rigid motion, this is also called an isometry. Okay, isometry. This is a function that maps a figure onto a new figure without changing its size or shape. So this is just like our first four transformations, a translation, a rotation, a reflection. Those don't change the size or the shape. Now, we've dealt with congruent before, so let's just, rehash this. So congruent is when a figure can be transformed onto another by rigid motion. This has the same size, same shape. The corresponding angle measures and corresponding side lengths are the same. So this means that we are dealing with the same shape if we transform it using a rigid motion. Now, Below, we got two things. These are just general vocab that I'm going to be using as we go through this. The pre-image is the original figure before the transformation. The image is the new figure after the transformation. Now, this has a new notation that I want you to get used to. All right, let me go through and let me pull up the pen tool. Now, when we go through and deal with this, we have to make sure that you understand what I mean by what changes. A prime symbol is an apostrophe. I'm not able to get my pen tool up. I don't know what's happening, but we'll deal with that later. So, whenever you see a image, the shape after you move it, that's going to have a little apostrophe on the letter that corresponds with the original one. So you're going to see that as we go through our practice on the bottom. But let's go through, let's take a look at our next thing. Now, a couple things are preserved under isometries, and a couple things are preserved under dilations. So for isometries, all the angle measures are remaining the same. Parallel lines are going to remain parallel. Collinearity is maintained, so any points that are on the same line should still be on the same line. The distance of the side links are going to remain the same. And the orientation, so whatever the letter order is in the name, that's going to maintain that same orientation. Now, the only thing that's going to change up is if you reflect, then, certain areas where those letters are at, they're going to flip-flop over to the other end. Then over here, we got our angle measures. Our angle measures for dilations are going to stay the same. However, when we get down to distance, that's going to be where stuff starts to change. Now, distance is essentially talking about what size it is. So we've dealt with dilations. These are just us talking about similar figures. All the rest of the stuff with the figures will stay the same. Same letters, stuff that's on the same line is on the same line, stuff that's parallel is parallel, but the side links slash size of the shape are not going to be the same. Okay? All right, let's get up out of here. We got one last thing. We got four problems on the bottom. Then I want you to go through and tell me which one is which. Okay? So let's